Hey everyone, hope you guys are doing well. So in this video we're going to be discussing about the highly availability of Kubernetes cluster. So if you are running your cluster on AKS, EKS or GKS, then this is not an issue for you. But if you are managing a self-managed cluster, then this is something which is really important for you to be implemented in your cluster. So generally what people have when they spin up their cluster is they have multiple worker nodes and one master node. Any request like that's any command from being executed by your DevOps engineer, or any request from your worker nodes will be served by this one master node, because you only have one master node. Your workloads, like your application runs on your worker nodes. These worker nodes, you may have multiple worker nodes, and you may have multiple pods for your application, so you may have high availability for your application. But for the cluster, you may generally, in most cases when you spin up your cluster, you will have only one master node. That means because it is the master node that manages the whole cluster, like let's suppose a pod crashes, so it is the job of the master node to bring back that node again, or to spin up another node in place of that node which has just died. So basically it is the brain of your whole cluster, right? So if you want to make sure that your cluster stays healthy and it works as expected, then you gotta have more master node, at least 3 master nodes, so that even if one of them goes down, you still have 2 master nodes managing your cluster, right? So this particular setup is called stacked etcd cluster. And what I've seen is people, what they do is they have their they spin up multiple master nodes, and then what they do is they place a load balancer, and they spin up another virtual machine or EC2 instance, configure Nginx in that EC2 instance, and then try to load balance the request between these 3 master nodes. This is good, but this is not good enough. Why is it good and why it is not good enough? This is good because it is doing the load balancing, and it is doing the it is splitting the request. So even if this goes down, you still have these 2 nodes or master nodes managing your cluster. But what if this EC2 instance or this virtual machine itself goes down? This will again, this is again another single point of failure in your cluster. So this doesn't really solve the problem, right? The whole point of having multiple master node was not to have any single point of failure, right? But in the attempt to have this, you created another problem. Like you have multiple master nodes, but you have this single EC2 instance that can go down. So this is not as good a solution as we would want to have, at least in production grade applications which are highly critical in nature. So instead of this, or spinning up an EC2 instance and configuring Nginx or HA proxy, the better approach in this case is making use of cloud providers load balancer, right? And because cloud provider load balancer, it is the cloud provider that manages that load balancer, so the chances of that load balancer going down is close to negligible. So that means that by using the cloud provider load balancer, you have now a highly available Kubernetes cluster that has no single point of failure. You have multiple master nodes, the load balancer is managed by the cloud provider, and then you have multiple worker nodes to manage your application. So this is what I have been implementing in the solutions for companies and organizations I have worked with, and the exact same implementation we're going to be implementing in the practical. So let's jump right into the practical. Okay, so we're going to provision the infrastructure using Terraform, and once we're done with the infrastructure, we're going to do the configuration using Ansible. Okay, so right here I've got two folders. One is for Terraform Infra and another one is for K8s Ansible. Okay, so if I open this folder, I have a main.tf file here, and I'm using AWS as provider, and I'm generating SSH keys because I need to log into those EC2 instances so that I could configure them and install the dependencies required for Kubernetes. Okay, and then obviously you need, whenever you want to spin up EC2 instances, you gotta have your own VPC. Okay, if you don't understand what is VPC, you need to spend some time understanding that. Otherwise it will be difficult for you to understand, especially these practicals which we are performing here, because these are I'm trying to mimic this production scenarios and implementing things as if we are doing in production. Okay, so we are spinning up a VPC. This is the server of the VPC 10.0.0.0/16, and in this VPC we are spinning up two subnets, subnet A and subnet B. Why two subnets? For high availability. Okay, and then two subnets in different availability zones, and then internet gateway is required so that you could give access to the internet. Okay, and then the route table, and then the route table association. So this is general VPC concepts. Then we are creating the security groups and allowing port 22 so that we could SSH into the EC2 instances. And then obviously these ports are required for the QP API server. Node port services uses these ports, and then for internal communication within the Kubernetes cluster you need these ports. Okay, one thing you have to understand here is, here the server range is in the internet 0.0.0/0. That means I'm opening this port for the internet, but here if you notice, the server range is the server range of the VPC. Okay, so these ports are only available from within the VPC, but these two ranges, this one and these ranges, are available from outside the cluster as well. Okay, and then we are provisioning master nodes and worker nodes. So depending upon the number of worker nodes we need, we are specifying the counts here, the image Amazon image ID, instance type, subnet, security group, SSH keys, and some tags here, and same goes for the worker node. And then the important thing here is, because we are implementing highly available Kubernetes cluster, so to make things highly available you need to have, like we mentioned before, we need to have a network load balancer. So here we are provisioning a network load balancer, and then we are opening the port 6443 because that is the port our API server uses, QP API server, and then we are forwarding that any request on this port to the master nodes. Okay, so we are creating a group of master nodes, and then that group is attached to this load balancer. So this is what we are doing here. So with this, our infrastructure is ready, and just to show you the variables I'm using, the region is US East 1, this is the image ID, I'm using T3 medium, and then I'm provisioning two master nodes and two worker nodes. So let's provision this infrastructure, cd into this folder, and then Terraform. I'm directly doing Terraform apply because I've already done the Terraform init and Terraform plan, but you guys make sure you do Terraform plan and Terraform init both. Okay, so this may take some time, and once it is done, we will get the I need to explain the output things here as well. Here in the output we'll get the IPs of the master nodes, worker nodes, and then the DNS of the network load balancer, and also the SSH keys. So we'll get an SSH key here as well, because and then we're going to make use of that SSH key. See, it has generated the SSH key here. So it is still working. So once this is done, then we'll move on to the Ansible part. Okay, so we have the infrastructure now ready. This is the IPs of the master node, this is the IPs of the worker node, and this is the network load balancer DNS. Okay, so now let's move to the Ansible part and configure these servers. So we know that we have, whenever we want to manage any server using Ansible, we have to specify them in the inventory.ini files. Okay, so here is the inventory.ini file. All you have to do is to just copy these IP addresses. This is the IP address of the master node 1, then master node 2, this is the worker node 1 IP, and worker node 2. So just to give you a quick rundown, so here I've got two groups of hosts. One is the master group and one is the workers group. In the master group, I've got two master nodes. This is master 1 and this is master 2. And here in the workers group, I've got two worker 1 and worker 2. And then I've got another group which has got all the nodes, like the master nodes and all the worker nodes. Okay, so I've got three groups of nodes, and first thing first, we have to prepare these all four nodes for Kubernetes, like disabling the swap, loading the kernel modules, and then installing the containerd, and then also installing the kubelet, kuberium, and kubectl. Okay, so these are some of the general steps which we do whenever we provision any EC2 or virtual machine and we want to use that either as a worker node or as a master node. Okay, so this particular playbook, all.yml, this particular playbook does all of that, and we will execute this module on all the hosts. So hosts is all. Okay, this all refers to this group. Okay, so let's go to cd into this folder and let's execute this playbook. Ansible playbook -i -in inventory.ini, and then specify the playbook name, so all.yml. So this will install and perform all of these tasks and prepare all the nodes for Kubernetes. This will take some time. I'll pause the video, and once it is done with this, I'll come back and then continue with the rest of the stuff. Let's pause it here. Alright, so now all the nodes are prepared. Now they can be used as a worker node or as a master node. Okay, so now we have to initialize the cluster. So to initialize the cluster, here is another playbook I've got, and here it has got some tasks, and what it does is it makes use of the kuberium init command and initialize the cluster. So one thing we need to understand here is, because all we are trying to achieve here is we're trying to achieve a highly available Kubernetes cluster. That means that for that we're using Amazon NLB. So the control plane endpoint will not be the default one which we use whenever we provision any single master node cluster. In this case, we have to use the control plane endpoint as the DNS of the NLB which we've just provisioned. Okay, so let me grab what was the DNS. Let's cd into that folder and apply Terraform output. So this will actually show me the DNS of the NLB, because I've actually lost that one here. So just trying to get the output again. So here, this is actually the DNS of the network load balancer. I'm going to copy this and paste it here. Okay, that is what we have to do. And rest is, there's not much. You guys can go through this and you'll be able to understand. So we are doing the Kubernetes kubeadm init here, and then we are specifying the control plane endpoint is this, and third upload, because the rest of the nodes, because we're doing this on only one master node, and once the initialization of the cluster is done, the other nodes will then join, because we have another playbook here which says join masters. Okay, so we've got two master nodes. One will first initialize the cluster, the second one then will, after the cluster is ready, the second master node will then join the cluster. Okay, so let's save this. You can see here that this will only run on the master one. Okay, so I've got two masters, master 1, master 2. So this playbook will only run on master 1. So let's execute this playbook. So this will take some time, and it will then initialize the cluster. Okay, so our cluster is now has been provisioned, and it has got only one master node. So let me, just to confirm things, because we have got the IP addresses of the master nodes, so let's SSH into the master one and see and confirm things, just to show you guys. Okay, so I'm gonna SSH into SSH-I, because we have got the key as well, like the SSH key. So we're going to make use of this SSH key and try to SSH into the master one. And then we will try to run the kubectl commands there in the master node, and we should get one master node. Okay, so let's say kubectl get nodes. See, we have got our Kubernetes cluster up and running. It has got only one node, and that node is control plane node. Okay, so now what I'm going to do is I'm going to execute this join master playbook, and this playbook will be executed on all the master nodes other than the master one. Okay, excluding master one, it will execute on all the master nodes. So if I show you here in the masters group, we have got two masters, so it will not execute on master one because it is already part of the cluster. It will execute on this master node. So say suppose we have few other master nodes as well, you can extend this list, and this join will execute on all those master nodes as well, excluding the master one. So let's do the join master. So once this is it is done with the execution of this join masters.yaml, we should be able to see two master nodes in our cluster. Okay, so let's wait for some time. So here you can see that it is done with the execution of the join master.yaml playbook. And just to confirm things, whether our second master has joined the cluster or not, I am in this my first master node. I'm SSH into that one. Earlier when we ran this kubectl get nodes, we got only one node. Now if I run this command again, I should get two nodes. Yes, we can see that we have got two nodes, and both of them are control plane nodes. Okay, so now what we are going to do is we're going to join our workers nodes as well. So here we've got another playbook. This is called worker.yml, and it will execute on all the worker node, and it will try to join the worker nodes to the cluster. Okay, so let's run this. So again, it will take some time, and we'll be then able to get those nodes as part of our cluster as well. Okay, so our worker nodes has now joined the cluster, and just to confirm, let's go to our master one and try to run again kubectl get nodes there. Here you can see that we have got 4 nodes, and 2 of them are control plane node, and these 2 are worker nodes, and this is ready, but this is still, it has still some pending tasks, so that is why it's still not ready. So let's run again. It's going to take some time, but it will eventually be ready. So this is how you provision a highly available Kubernetes cluster using Amazon or any cloud provider's network or load balancer. Okay, and we have used Terraform, we have used Ansible. So this is how you do things in production.